Hey, what's up, guys? This is Cheng here again. So today, again, daily challenge problem number 417, Pacific Atlantic water flow. Okay, so you're given like m times n matrix of unnegative integers representing the height of each unit cell in the continent, and the Pacific Ocean touches the left and top edges, and the Atlantic Ocean touches the right and bottom edges. And the water can only flow in 4 directions and from a cell to another one with a height equal or lower, right? Which kind of makes sense. And you need to find the list of grid or the cells, right? So that the water can flow to both oceans. And the order of return grid does not matter. And the constraints m and n are less than 150, right? For example, we have this kind of like 5 by 5 grid, and then the positions that the cells, right, that can flow to both oceans are the ones that within this parenthesis, right? Because this one, remember, so the water can only flow from the higher units to a lower unit, right? So for example, this 3 here, there's no way this cell, the water in the 3 can flow to Atlantic Ocean, right? Cool. So for this one, for this problem, I think the naive approach is that, obviously this kind of, as long as you see like a coordination with like 4 directions, it's definitely you can either use a BFS or DFS approach, right? So for this one, I mean, the naive approach is that, basically we try each of the coordinates, right? We use each of the coordinates, and then we do either BFS or DFS traverse for each of the cell. And whenever so while doing the traverse, we also maintain like 2 flags, right? I mean, if this I, right, basically if this if the current I if the current cell reaches the top row or the leftmost column, then we mark the specific flag into true. Similar for the Atlantic uh, Ocean, right? We mark that one as true whenever we touch the rightmost and the bottom row, right? And then in the end, we check if these 2 flags are both true. If it is, then we simply return that. Of course, while doing that traverse, we also need to make sure, the new one, right? The next cell, the value has to be either equal or greater than the current one, right? That's the only thing we need to be careful. So for that, obviously we can get the final answer, but as you guys can see, that's the time complexity for that is what? So basically we need to traverse each cell, and for each cell, the worst case scenario is we have to traverse the entire grid, which means that, let's say the m and n, right? So it's going to be a m times n to try each of the cell, and for each cell we need to do another m times n traverse, right? So which means they're gonna m times n square. So can we do better, right? Can we only do m times n instead of doing this kind of nested traverse, right? So the answer is yes. So how can we do it? Basically, we just do a either DFS or BFS traverse, And what's going to be the condition for that? So basically, we can see that, on the first row and the first column, right? All those elements, right? All those elements, all those cells, they will always be able to flow to the Pacific Ocean. If we start our traverse from this based on these cells, right? And then if we can traverse all the cells, and then when we stop, the visited cell are the cells that can definitely flow to the Pacific Ocean, right? Of course, while we're doing this traverse, we have to compare the values in a reverse way. Basically, we only traverse when the next cell has a value either equal or greater than the current one, right? Because we're doing this traverse in a reverse way, right? Because we know we're sure that all the cells can flow to specific, and we try to find any other cells can flow to the current cells. Basically, after that traverse, right, we have a list of cells that can flow to the Pacific Ocean, right? And similarly for the Atlantic Oceans, right, we start from the last column and the last row, right? And then we do the same traverse, and after that we have like a visited set which tell us what are the cells can flow to the Atlantic Ocean, right? And in the end we simply need to do an intersect, right? Intersect of those two lists, and then that give us the answer, right? Since we only do the traverse twice, so it's going to be a m times n, right? We're going to do a basically m times n to traverse the Pacific Ocean, and then another time plus m times n to traverse the Atlantic, and then another one in the end to find the intersects, right? So in the end, it's going to be a 3 times m times n, which is m times n. All right, so let's code the second one since it's a better solution, right? Okay, so I'm going to create like helper functions, right? It's going to be a DFS. So it takes stack, like the initial state of the stack, right? And then assuming we have that DFS, right? Because it takes a stack of the starting cells, and then we have this kind of the main structure, which is this one, right? So this one and length of matrix of 0. Let's do a sanity check here. So if not matrix, right, we simply return not, right? So we have we need to have like two lists to start to do the this Pacific Ocean and Atlantic Ocean traverse. So I'm going to use the P represents the Pacific, and then have A represents Atlantic starting cells, right? To start with, we can do we can do this one, the range M, right? So this one, that means that we're looking through the each row, right? So for each row, the Pacific is what? It's the I dot 0, right? Which means it's this one. That's the Pacific one, and this one is the Atlantic one, right? So for the Atlantic one, we have we have a I dot n minus 1, right? So similar for the rows, right? So we need to have like this range n here, right? So for the row, we have 0 and j, right? Similarly, for the Atlantic Oceans, we have n minus 1 and j, okay? And then we're gonna have like a DFS, right? So I'm going to reuse the same variables. It's gonna be a DFS of the Pacific, right? And then we have like a dot DFS of a. So after this one, I reuse the same variable here. So after this one, the P will store all the cells that can flow to the Pacific Ocean, and the A will be the cells that can flow to the Atlantic Ocean, right? And then the rest is just like to do an intersect, right? So for the intersect, we can simply do this, right? So if this for each cell in the P here, if the C in the A, right, and then we just append this one to C, right? And then in the end, I return the answer. So that's the basic logic. And then let's implement this DFS, right? So this DFS is very standard DFS template. Plus that, the comparison between the values of the adjacent cells, right? So we have this one, the 4 directions, right? This one, and okay, and then we have a scene dot set of the stack, right? Because we need to initiate this scene to the stack from the stack, right? And then while stack ij gonna be the stack dot pop, right? And then for direction in directions here. New I equals to I plus D0, and the new J equals to J plus D1, right? Then if the I and it's in the range of 0 to m, and the new J is in the range of 0 to n, right? And the matrix, right? Okay, and this one, and new I and new J are not in scene, okay? And the matrix of new I and new J, right? Like what? It's greater actually. So this one has to be greater, right? Either equal greater than the matrix of I and J, right? Then we do a step. Append new I, then the cells to the stack, right? And we also gonna add this one to the scene. So here, why do I? So the reason we still need to check to do this check is because these two values could be the same, right? I mean, if they're the same, if we don't do this one, we'll revisit the same cell, right? So here I return the scene set, right? Cool. I think that's it, right? So if I run the code here, invalid. Oh, here. Yeah. All right. Accept it. Submit. Cool. So this one is pretty fast, right? Because the time complexity for this one is just m times n, right? Because uh we have one m times n, two times m n, and then third one. They're parallel. They're not nested. Yeah, cool. I think that's it, right? So I think it's very classic, a little bit a variation of a standard DFS or BFS templates, and plus a few tweaks, right? Basically, which means that we have to do the DFS and BFS in a reverse way, so that we also need to reverse this kind of conditions while we're doing this the DFS traverse, okay? And then in the end, we just get the intersection between those two lists. Cool. I think I'll stop here, and thank you for watching this video, guys, and stay tuned. See you guys soon. Bye bye.